Hi, this is question 7 from the AQA Mechanics 3 June 2011 exam paper. In this question we've got two smooth spheres A and B. They have equal radii and masses 4m and 3m respectively. The sphere A is moving in on a smooth horizontal surface and collides with sphere B, which is stationary on the same surface. So it's going in this direction and collides with B here. Just before the collision, A is moving with speed u at an angle of 30 degrees to the line of centres as shown in this diagram. Immediately after the collision, the direction of motion of A makes an angle alpha with the line of centres as shown in the diagram. The coefficient of restitution between the spheres is 5/9, and we first of all want to find the value of alpha, and this is a 10-mark question, so it's quite a lot of work to do here. So what we're going to do is we're going to have a look at 3 different parts of this, and we're going to form equations using 3 different parts of this, and hopefully at the end we'll be able to work out what this angle alpha has to be. So we're going to have a look at the conservation of momentum in the direction of the lines of the centres. So what we're saying, along this line momentum is going to be conserved. We're also going to have we're going to take into account the momentum of A is unchanged perpendicular to the line of centres. So in this direction the momentum of A is going to stay the same. Okay, and we're also going to have a look at the restitution along the centre. So we're going to take into account the coefficient of restitution, and we're going to use Newton's law of impact that tells us that the coefficient of restitution is equal to the speed of separation divided by the speed of approach. Okay, so starting with this part here, the conservation of momentum in direction of the line of centres, so that's in the line of centre, our mass times initial velocity of A plus our mass times initial velocity of B is equal to the mass times our final velocity of A plus our mass times our final velocity of B. So well, our mass of A we know is going to be 4m, so I'm going to start by writing 4m times by and in this direction here we're going to have u cos 30, so 4m u cos 30. Okay, and plus and then it's going to be our mass of B, which is 3m, times by our initial velocity of B. Well, that's stationary to start with, so this part here is just going to be 0. Okay, so that's going to be equal to, and then we've got the mass of A times by the final velocity of A, so the mass of A is 4m, and the final velocity of A, well, we're going to call that VA. So this here is VA, but we of course want this along the line of centre, so it's going to be VA cos alpha. So that's going to be VA times cos alpha. Okay, and then we've also got the momentum of B. Well, that's going to be the mass of B, which is 3m, times by, and B is going to move off in this direction here, so that's just going to be VB. Okay, and that's because it's moving along the line of centre itself. Okay, just simplifying this, cos 30 is root 3 over 2, and all the m's here will cancel each other out, so this will simplify to 4u root 3 over 2, which is just 2 root 3u. And over here we'll have, or the m's will cancel each other out, and we've got 4 VA cos alpha plus 2 VB. Okay, and there you go. I'll just make that a bit clearer. So that's root 3. Yeah. Okay. So this is an equation that links u, which is our initial speed, VA, VB, and alpha together. Okay, we're now going to form an equation taking into account the momentum of A is unchanged perpendicular to the line of centre. So perpendicular to the line of centre, the momentum of A before impact will be equal to the momentum of A after impact. So the momentum of A before the impact will be the mass, which is 4m, times by its velocity before in this direction, which is going to be u sine 30, and that's going to be equal to the momentum of A after impact. So that's going to be 4m multiplied by VA sine alpha, and that will be in that direction now. So it's going to be VA sine alpha. Okay, now we can simplify this because again the m's will cancel each other out, and sine 30 is a half. So this is going to make that 2u is equal to, and that simplifies to 2u, and over here we've lost the m and we've got 4 VA sine alpha. Okay, and I'm going to write this as VA is equal to, and it will be 2u over 4 sine alpha, which is going to be equal to u over 2 sine alpha. Okay, and there you go for that part there. Now for the next part, we're going to look at the restitution along the centre, so in this direction here. So our coefficient of restitution, which we've been told is 5/9. So we've got 5/9, and that's going to be equal to, and it's going to be the speed of separation, and the speed of separation is going to be VB take away and along the line of centre it's going to be VA cos alpha. Okay, so that's the speed that they're going to separate by, and also the speed of approach. Well, the speed of approach is a little bit more straightforward because B wasn't moving to start with, so that's just going to be u cos 30. Remember, this is along the line of centres. Okay, so if we can rearrange this now, I'm going to, well, we know that u cos 30, sorry, cos 30 is root 3 over 2, so I can say that this is going to be equal to, and while we're at it, we also know that VA is going to be u over 2 sine alpha, so I'm going to bring all that together. So I'm going to say VB take away u we're going to do VA times by cos alpha, so it's going to be u times cos alpha over 2 sine alpha, so u cos alpha over 2 30, but all of that over u cos 30, and cos 30 is root 3 over 2, so it's going to be u times root 3 over 2. Okay, and I'll just tidy this up a little bit. So if I multiply both sides by this here, that's going to make that 5u root 3. I don't like the way that I've written that. 5 root 3u over, and 2 times 9 is 18. Okay, so I've just multiplied both sides by this here, and that's going to be equal to VB take away u cos alpha over 2 sine alpha. Okay, and I've got an equation for VA over here, so I'm also going to aim to get an equation for VB over here. So that means that VB must be equal to this plus this. So VB is equal to 5 root 3 u over 18 plus u cos alpha over 2 sine alpha. Okay, now what we're going to do is we're now going to bring all of this together so that we can write down what we can write down a value for alpha. Right, so I know what VA is equal to and I know what VB is equal to, so I can sub that into this equation that I've got up here. So I'm just going to create a little bit more room for myself. Right, okay, and what I've also done is I've highlighted the equations that we are going to need now. Right, so I'm going to sub this into here and I'm going to sub this into here. So that's going to be 2, and I'll change the colour of my pen. Blue again. Okay, so we've got 2 root 3 times u, and that's equal to, and we've got 4 VA cos alpha, but VA is u over 2 sine alpha, so that's going to be 4u cos alpha over 2 sine alpha, and I'm just going to write that straight down as 2u, and cos alpha over sine alpha is going to be cot alpha. Okay, I hope that's okay that I've just subbed that straight in. I'm just trying to save space, to be honest. Okay, so we've got 2u cot alpha from there, plus, and we've got 2 times VB. And I'm pretty sure that's a 3, I beg your pardon. Okay. It must have got changed when I shrunk it. Okay, so that's going to be 3 times VB, so we've got plus, and VB is what we've got going on over here, so we're going to have 3 times this here, so that's going to be, if I times that by 3, I get 5 root 3u over 6 plus, and I'm going to times this by 3 and I get 3u cos alpha over 2 sine alpha, and I'm going to again write that as cot alpha, so we'll have 3u cot alpha over 2. Okay, now what's going to happen now is all of our u's here are going to cancel each other out. So we're going to lose all these u's, and at the same time I'm going to multiply everything by 6. So that means that over here we're going to have 12 root 3, and the u's gone, is equal to 12 cot alpha plus, if I times this by 6, I've got 5 root 3 plus, and if I times this by 6, I've got 9 cot alpha, and the u's have all cancelled each other out. Okay, so simplifying this, that's going to give me 7 root 3, or take away 5 root 3 from both sides, and I'm going to do 12 cot alpha plus 9 cot alpha, which gives me 21 cot alpha. Okay, so that means cot alpha is going to be 7 root 3 over 21, which means I will write that down. So cot alpha okay, and that means that tan alpha is going to be equal to 21 over 7 root 3, and that simplifies to it will be so 3 over root 3, and 3 over root 3 is just going to be root 3. Okay, so this simplifies to 1 over root 3, so tan alpha is just going to be root 3. I hope you're following. I've skipped a step there, but I hope that's okay. Okay, so and if tan alpha is equal to root 3, well, that follows that alpha is going to be equal to 60 degrees, and that's brilliant. That is, we've gone through all of this, and we've worked out the the value of alpha is actually just 60 degrees, and that's it for 10 marks. Okay, so part B, where can I do part B? Well, I'll start part B over here and then we'll see how we get on. Okay, part B says find in terms of M and U the magnitude of the impulse exerted on B during the collision. Now the impulse on B is going to be the change in momentum on B along the line of centre. So the impulse is going to be the change in momentum of B along the line of centre. Well, B was initially at rest, so the initial momentum of B was just 0. So actually it's going to be, the impulse is actually going to be equal to what the momentum of B along the line of centre is now. So that's going to just be the mass of B times by the final velocity of B. Yeah, so we would usually take away the initial momentum, but that's just 0 anyway. Okay, so the impulse is just going to be equal to that there. Now we know the mass of B is 3m, and we also know that the velocity B, well, we've got an equation for this, so I can just sub that straight in. So that's going to be 5 root 3 u over 18 plus, and we've got u cos alpha, and alpha is 60 degrees. So if alpha is 60 degrees, cos 60 is a half. So that's going to be a half of u over 2 sine alpha. So sine of 60 degrees is root 3 over 2. So that's just going to be 2 lots of root 3 over 2, which is root 3. Okay, so that's going to be equal to, right, so that's going to be 5 root 3 m u. So 5 root 3 m u over 6. So that's what 3m times by that is going to give us. Plus, and we're going to have 3m times by this here, but that's going to give us, so that's going to be u over 2 root 3, so it's going to be 3mu over 2 root 3. Okay, and if we simplify this, that's going to give us, well, if I multiply top and bottom here by root 3, that's going to be 5 root 3 mu over 6 plus, that's going to be 3 root 3 mu over, and if I multiply the bottom by root 3, that's going to be 6, and that's going to be equal to, if I add these together, I've got 8 root 3 mu over 6, and that's going to be equal to, and I'm sorry, I'm going along here with lots of equal sign, it's only because I've run out of room, and that's going to be 4 root 3 mu over 3, and that there should be what the impulses exerted on B during the collision. Okay, that was quite a long question. Hopefully you kept with that, and it was clear enough for you to follow. Thanks very much for joining me. I look forward to seeing you again soon. Take care.